how'd you do with finishing the table? And I don't know if I said the graph, but here's the graph of it. Notice we get to connect the lines because you can have a half an hour in here and that would make sense. But remember, if it's people, then you probably don't want to connect it. Now this ends up being a proportional relationship because it's a straight line and it goes through the origin. Those are two requirements to be a proportional relationship. What is the unit rate for this relationship? Well, the unit rate is how many square feet of concrete can Doug pour in 1 hour? Well, we could go back to the table. Let's see what the table says. In 1 hour? Oh, it's 25. So that's what you're looking for. You're looking to see the 1 hour mark, the 1 mark. So the answer to this question would be 25 square feet of concrete for 1 hour. Write an equation. Which equation below describes this relationship? Well, the proportional constant, the multiplier, is 25, and it's always set up where it's y equals the multiplier times x, so it would have to be this one. Will Doug finish the job in time? Yes, Doug's going to finish the job because he only has 1 more hour left. And he can pour 25 square feet. So 1 more hour left, 25 square feet is possible. Alright, I'm going to let you read this next problem on your own and see if you can answer A and B. Alright, let's go over this. Does the graph describe a proportional relationship? It sure does. The two requirements are it's a straight line and it goes through the origin. Straight line and goes through the origin. Remember, this is your origin here. Straight line. So yes, it is a proportional relationship. What's the unit rate? It's 3 ounces of water per 1 scoop of formula. Remember, a unit rate has to have the relationship though, so the denominator is 1. At a different location on the graph, show and explain how you can find the unit rate. Well, you can go over 1 and up 3, or you could go up 3 over 1, up 3 over 1, oops, I missed that, up 3 over 1, up 3 over 1. That's how you can find the unit rate. Write an equation to relate the ounces of water to the scoops of formula. So the y is the water, and the multiplier is 3, and x is the formula of scoops of formula. So there's your equation. How many scoops of formula must Vanessa use to make 9-ounce bottle for her baby? How many scoops? So what are we trying to find here? Well, we know that y is the water. We can look at the graph, we can look at the table. X is the scoops. What are they giving us here? They're giving us the water. So we have to put that in on the water side. And then, of course, we would solve this equation. And X is the scoops, so it would take 3 scoops for a 9-ounce bottle of water. Okay? Let's take a look at our next problem. Once again, I'm going to let you read this, and please highlight anything you find important. Alright, so we have 3 guys with their monster trucks, and they're going distance, or time, what am I doing? The lines on the graph below show the distance in inches that each monster truck travels over time. Alright. First off, Brighton states that each truck is traveling at a constant rate. Is this statement correct? Why or why not? Yes. And the 2 criteria are it's a straight line and it goes through the origin. There's your criteria. Goes through the origin. I'm going to keep rehashing that. Goes through the origin. Okay, if it wasn't constant, we would have something like this. That wouldn't be constant. That's not a straight line. What do the values in the ordered pairs given on the graph represent? Well, they're representing the distance traveled in a certain amount of time. Distance traveled, and that is our y, in a certain number of time, which is in seconds. That's what those represent. Find the unit rate for each boy's truck. Okay, well, let's take a look at Ben. Ben is, let's go back up here and take a look here. Ben, he is this one here, okay? So this represents, this 1-4 is telling us that the 4 is the inches, so 4 inches, that's not how you spell inches, 4 inches per 1 second. That's the unit rate, 4 over 1. So you have to put the y, which is this part, it's y over x. Y over x. Okay, so he's 4 over 1. 4 over 1, which is 4 inches per second, per 1 second. And Brighton was, the coordinates were 6, 8. I can just use those coordinates. And I can say, oh, it's 8 over 6, which is 4/3. So he is 1 1/3 inches per 1 second. And Boston, his coordinates were 4, 2. That's a 6, not a 2. 4, 2. So his is 2 over 4, or 1/2. So that would be a 1/2 inch per second. Which boy's truck is moving the fastest? Who's going? Well, 4 inches in 1 second sure seems the fastest to me. So that would be Ben. Alright, I would like you to finish 12 and 13. You have to summarize. So you may have to go back and find some notes that you took. Alright, this concludes our lesson on proportional relationships.